Welcome. So I'm happy to see so many people on the last day of the event. So this is the second session that we have for manufacturing. Before I start, I want to thank our sponsors. So we have the 5G Showcase sponsors, an entity, and the headline sponsor of the sessions, Microsoft. So thank you for sponsoring and making this possible. What we're going to talk today, so as you see from the title, we try to talk about how to break the barriers for the industrial 5G. Just to introduce myself, my name is Barbara Pareglio. I work in GSMA, and I'm going to be the host of this session. So I'm not going to spend too much time, but I want actually to start on the first part. So what we're going to have, we have quite a busy session today. We're going to have two panels, and in between we're going to have a presentation. So we're going to start immediately on the first panel. So let me introduce Moushumi Ghosal from Microsoft.
Thank you, Barbara, and welcome everyone to the MWC Las Vegas session for breaking the barriers to industrial 5G, breaking down barriers to industrial 5G. I would like to welcome the executive panel along with me, Mr. Sudhir Arni, Senior Vice President, Business Operations from Site Machine, Mr. Tsui, Senior Director of Sales Engineering and Solution Architect for Hyperscalers from AT&T Business, and Mr. Blake Clarkson, Chief Operations Officer at Webex. Please come on stage. So we'll start off with a short presentation on how the manufacturing industry is doing and a few slides on that. And then we'll go over a panel discussion, a conversation which will have some question-answer sessions. And then we'll close off with some closing remarks and some takeaways from this session. So to succeed in today's dynamic world, manufacturers need to become more agile, resilient, and sustainable. Hence, the industry is going through a period of drastic change, disruptive change. As a result, the companies need to invest in capabilities to make their products and operations smarter. And how to do that is the companies need to invest in technologies wherein they have introduced digital transformation, Industry 4.0, IoT, IDOT convergence, artificial intelligence, and driving basically a digital-first culture. Now, smart devices, automation, the cloud, and the mobile broadband technology is driving the Industry 4.0 initiative. How we are doing this? So all these, you see on the screen, there are some metrics that we have from IDC Manufacturing Insights, where you see there are many things that are fueling the demand for private and public 5G networks. And along with the edge computing technologies, this will enable the capabilities for the next generation, the future of manufacturing. Now, as manufacturers look to connect the different smarter devices and leverage the telemetry data to make real-time decision making and operational efficiencies, private 5G network, public 5G network, as well as edge computing technologies will provide the foundation to achieve these goals. Now, what we have been hearing from many customers, or the vast majority of customers that we have been talking to, they are not looking to transform the manufacturing industry, but they want to enable and modernize all aspects of their business. So how they do that is the transformation basically would focus on customer outcomes, changing the manufacturer's mindset, and the business operations from end to end. Now, Microsoft's investment in this area is basically to focus on five key root priority scenarios. And you see those scenarios up here on the screen. The first one is transforming the workforce. And how we do that is to combine productivity applications, intelligent cloud services, and security to transform how people work. Building more agile factories. Now, how we think of doing that is we need to create a safe, secure environment, and with agile factory of the future, we need to bring in IT, OT, and industrial IoT together. Next one is on creating more resilient supply chain. We need to improve the service resiliency and profitability through intelligent supply chain planning and execution.
Sorry, you're good.
Now, the fourth one is engaging the customers in new ways to deliver relevant customer support experiences through connected field services and solutions that we can bring in marketing, sales, and service channels together. Now, how do we, and last but not the least, we have to unlock the innovations and deliver new services. How we do that is discovering new business value, and we need to bring in sustainable products and digital services. Okay. So first question to you, Sudhir. What are you hearing as the biggest needs or trends from manufacturing customers in terms of digital transformation?
Of course. So we've been talking to manufacturers for the last 10 years, along with Microsoft for many years now. One of the biggest needs that comes up again and again is we have so much data lying around. It's not that we don't have data. We have a lot of data. We want to use it to start doing analytics, start creating value from it, start solving problems. And problems could be anything. Just make more product or use the data to make your supply chain better. They're all struggling to use this data. That's one of the biggest challenges they're all facing. Reasons are plenty. To use that data, you got to go connect to the sources, get the data out. That's where truly a connectivity solution comes into play. But even after you've taken the data out, the data is quite chaotic. It is all in different protocols. It's all in different kind of formats. To bring it all together into a standard foundation is one of the other bigger technology challenges that they're all facing, and they're looking for a solution for that. But hands down, every factory that we go to, we see tons of data. They want to use it. They're waiting to use it.
Exactly. Ricky or Blake, you want to add anything?
Yeah, no, I think one of the challenges we see, as you mentioned, is also, how do we integrate the systems together, right? So a lot of times you can say we have a lot of legacy OT systems, and having SCADA data and Modbus data and different PLC controllers, and how do you connect them to IT systems, right? And oftentimes, we were just talking about it earlier here, the OT folks don't want to talk to the IT folks, right? They slow them down and it's complex, et cetera. And so sometimes they do this, what I call shadow OT, right? They'll just connect things themselves, which often leads to a lot of security problems. So for us, I think one of the challenges that we like to help our customers fix with partnership with Microsoft is that AT&T is obviously we have a lot of experience scaling out, delivering secure, robust, private cellular networks, right, from small to large, and obviously Microsoft has a strong history of securing enterprise applications, and together we can help a lot of our manufacturers and the OT folks figure out how to properly, securely integrate those systems together.
Right. Blake, you want to take a stab at it?
Yeah, I think the comment just made on IT/OT. I think IT people don't understand the complexities of OT, and I think I'm an IT guy by background, but I've worked in OT for the last decade. The coming together of the minds has got to happen. So it's going to be more challenging than enabling, probably for the next 5 to 10 years. But another thought, though, is that when we invented IoT and we think about data, we've driven it from compute up. And if you think back to how software, and I'm riffing right now, by the way, if you think back to how software was developed when we bought our first, Apple versus, IBM PC in the 80s, right? Everything was kind of command line, green screen, and then took a decade for the market to recognize we need graphical user interface, we need, human-centered design engineering. We see the same thing happening in IoT where it was, hey, let's throw a computer out there, grab data. Well, what about the human interaction? Right? How do we get, we can trust the data from a computer, but how do we trust the data from a human? How do we leverage the data from the computer to make the human better? Right? So the concept of, Internet of Worker first, right, is something that I think the market's kind of ready for, and we need to start rationalizing. And we're seeing this, clearly across, not only all frontline workers, but specifically, manufacturing.
Absolutely. Thank you. Thank you all. Okay, the next question to to you. I'll start with you, Ricky. What are the biggest challenges? For example, as we think about digital transformation in manufacturing, what do you see the manufacturers needs to be aware of?
Yeah, I think I mentioned it earlier. I apologize, I skipped the question and answered the second one first. But yeah, it goes around that whole, the securing the integration, right, between OT and IT, right, and helping our customers realize that you can't just stick OT systems into into a network or into the public internet and just be done with. It might work functionally, right, but then you're exposing yourself to quite a bit of threats that didn't exist back in the day when you had a closed SCADA system, right? Like if you think of the common cyber attacks on the IT side, now their surface attack has expanded to OT systems, right? So you think of ransomware, where ransomware caused a lot of problems when they took over your laptop. Now what happens if they took over your PLC controller, right? What happens if they shut down your, even as nuanced as a cyber attack on your HVAC system, right? Think of a factory and they hack your air conditioner and they shut it down, right? Overheating your factory, right? Like we're seeing those type of attacks that are quite prevalent, right? And as we start integrating this, having this digital transformation in the factory.
Right. Anybody wants to add anything?
I'd love to add one thing. We see that a lot of manufacturers right now are being bombarded by so many different offerings in the market. And one trend that a lot of them have seen has not worked is, let's start whatever we want to do as a digital transformation on the shop floor with an application-first approach. Let's go and do a predictive downtime application. Let's go and do a predictive quality application.
Right.
We recommend to each one of them that that's a challenge and a trap that they would get into because it's not scalable.
Right.
We always tell them, think about a data-first approach. The real problem and complexity is get your data, standardize it. Once you've standardized, you're not thinking about one application, you're thinking about hundreds of them. But that is truly a challenge, and it's lots of efforts which have gone on as a pilot and not succeeded. And a lot of manufacturers are struggling to come out of that. But that's a challenge that we truly try to educate the market about, and we've seen it work. But it's something that still needs to be spoken about quite a bit.
And there's still the ROI question, right? So having a CFO office involved is usually incredibly impactful. I've spent 25 years in IT. One of my favorite stories for my kids is the effect that virtualization had on data centers, specifically servers.
Right.
And if we can remember back to how that played out, right? It was not about CIOs running to VMware saying, let me buy. It was actually, Wall Street CFOs in 2007 that said, we should be virtualizing all this CapEx expense. And by selling that, widget, if you will, to the CFO, it moved a market.
Right.
And so, we have to be certain when we're looking at IT and OT budgets, right, that the finance department is involved. Because, industrial market is all about labor optimization, right? And they're starting to now throw technology on that labor. But if you're not proving a strong ROI, it's more a science project.
Yep, thank you. Okay, the fourth question for you, Blake. What are the best practices would you recommend for overcoming these challenges? Like, for example, the best way to work through the different types of applications we talked about, and what security considerations, I think we touched about a little bit, we should consider, the manufacturers should consider.
Yeah, I think when we're looking at manufacturing, and I have an IoT kind of background, so I'm always thinking of it from kind of data on up. I think the first thing we really need to do from a best practice is rationalize the effect of that data on the worker. I talked about that a little bit earlier, but I love analogies. Look at how we've moneyballed baseball and football, right? You put sensors on an NFL athlete. Starting left tackles have shoulder pad sensors, video is a sensor, and they're able to prove that, gosh golly, they're the best left tackle in the market. They deserve $30 million a year. And the unions have bought off on it. Oh my gosh, incredible, right? So you have this opportunity to really kind of rethink about workflows. And so I think that's the most important part of the equation. On the security side, I mean, I'm an old PKI guy, so I love, PKI became Bitcoin, amazing, oh my gosh, right? So, technology's been available. It's been people's adoption of it that's been the problem. So I think with, centralized and now distributed cloud, we were talking about that earlier, the technology's not the problem. It's the buy-in from the purchaser. But it feels like things are getting a lot more aggressive. I don't know if it was COVID-induced or what, but in my market, customers are much more willing to experiment and aggregate than they were pre-COVID. Maybe it's remote workage. I don't know what, but it feels like we've got a nice synthesis of convergence of the cloud at the edge with private wireless, 5G deployments, and then more cost-effective, smarter compute right in the hand. And so it's the systems approach is becoming real.
Awesome, thank you. Next question, can you tell us about any recent deployments that you have done with customers? Any other use cases that you're seeing resonating among them? Sudhir, you want to go first?
Absolutely, yeah. There's quite a few that we're working on. One that comes to mind is with one of our tier 1 automotive supplier customers. They supply a lot to the electric vehicle supply chain. We ended up standardizing all their data. It starts from connecting to their assets, whatever network connectivity solution that you use in a number of places becoming 5G. We didn't use 5G here. Get the data out from different sources, standardize it. And we deployed at-scale machine learning for them on top of this data foundation to start solving their quality issues. And their scrap went down by about 50%. It's one of our first examples where we are truly taking the same machine learning application, deploying across 7 of their factories globally. It's typically a hard thing to do because it's extremely expensive to take one machine learning application from one side to another and keep scaling it and deploying it. But once you do that on top of the data foundation is standardized, it becomes easier to scale and cost effective. Right. ROI is massive. Number of examples like that, but that's one that comes to mind for sure.
Awesome. We'll close off with one last question. Enterprises requires multiple partners to enable their end-to-end scenarios. And how do you think you are taking advantage of Microsoft's partner ecosystem to build your solutions which will meet the needs of your customers? Blake, you want to go?
Oh, sure. Yeah, I mean, as I mentioned before, I think the convergence of distributed cloud at the edge with low-cost, pervasive networking, CBRS domestically, the evolution of 5G networks that can be multi-application or single application, but then can run on the edge is, that's a kismet moment. So we're incredibly excited to be working with Microsoft's tech stacks, and really I'll say democratize the data at the edge, which we've been talking about for 20 plus years. Mm-hmm. But it's finally happening, and that's a pretty exciting thing.
Thank you. Thank you all.
Thank you.
Thank you.
We'll just close off with some final remarks and next steps.
You answer the question. Sorry.
No.
So 5G industry 4.0 are the key enablers, as we talked about, for digital transformation. Microsoft is developing the edge compute solutions with private MEC and public MEC, which has got very seamless deployment capabilities and very similar to what we have in the Azure regions. And we'd like you to try it out and come build with us so that we can show you how easy it is to build MEC solutions. We can learn more. We have the links out there, Cloud for Manufacturing and Azure for Operators. Thank you all for being here in the session today.
So now we're going to have the intermediate session. So we have a presentations. So this presentation is going to touch a little bit more on security. We already had a lot of topic where they were touching on security. So now I want to introduce on the stage Leonie Burakowski from Palo Alto Networks. Please come to the stage.
Okay, welcome to our security session. I'm in charge of product management, everything 5G with Palo Alto Networks. So we all know about security attacks. I will not name all of them. We know them in pipeline, we know them in manufacturing with water utilities, a lot of espionage. It's happening all the time. I just put it here, several numbers. It's growing. On another hand, industry is moving and adopting digital transformation. Some industries doing it quicker, some industries doing it slower, and we are seeing first numbers. For example, I recently saw milk production grew 50% the moment you are connecting cows and doing a lot of through 5G networks. Rice production is growing. So it looks funny, but it's really huge business. If you are growing rice production, you can feed much more people in ports, airports. So we are seeing first numbers, how it's efficient to adopt 5G and transform industry to 5G ecosystem. What about security here? And this is an elephant. This is my main slide of the problem statement. If we do believe that industries are doing digital transformation, if we do believe that 5G ecosystem is good ecosystem for them to do this digital transformation, there is a huge elephant in the room, and we should address it. And this elephant is that security technologies used in the past are irrelevant. You do need pipe security. You do need connectivity security. Usually it's layer 3, layer 4, NAT, denial of service, of course. Without connectivity, nothing will work. But this is not an ecosystem that will allow and give confidence to enterprises to adopt this system. Because enterprises need different layer of security. They need what we are calling enterprise-grade security, and I will discuss it on the next slide. So usually when I'm doing big sessions with customers and partners, I'm not moving from this slide unless it's fully understood and clear. Everything else is irrelevant if we disagree on this slide. And usually I'm answering here a lot of questions. Technologies that were used in previous generation are important to have, but this is connectivity layer, networking layer, pipe layer. It's not enterprise-grade security. So for enterprises to move and adopt 5G really, we have to address it. Now let's discuss what is enterprise-grade security. And I spent a lot of time in creating this concept. It's very difficult to put some concept that is abstract enough, but also has a lot of legs in the technologies. I spend a lot of time bottom up, and we can really lose the conversation if we will start discussing different areas of technologies. If we are moving up, it can be, once again, we can completely lose the conversation on the level of so abstract that is irrelevant. So it took me several interactions and quite a lot of time to design it, and would love to hear your feedback. So first of all, we need continuous visibility, continuous monitoring. Why continuous? Because application can be good initially, and in 2 months it can be bad. So you need continuous visibility. Without that, everything else is irrelevant. You can't prevent things that you don't know about. Now let's go vertical by vertical. First, it's all layers. And here I should praise GSMA for a great work in security on different layers. GSMA is doing fantastic job on different signaling layer security. And I was working with GSMA and some partners of customers and vendors, and we create first ever data layer security. Because this is where a lot of bad things are happening. This is where you have your malware and ransomware running. This is where you have command and control if you have infected devices. We had a lot of talks about IoT devices. When they are infected, depends, of course, what is the purpose of this infection. If to attack, they should call command and control and coordinate this attack. And we already saw examples of network going down when you had attacks from a lot of infected IoT devices. If it's for spying, you should have some remote information retrieval. Once again, it's running inside data layers. So this is why all layers is so important. Application layer, obvious, signaling data layer, and also I added here per slice. Because for the first time, you can do in 5G dynamic per slice security. It was impossible to do in 4G or 3G. Now, in addition to bandwidth, in addition to quality of service, you can give different security policies for different enterprises and do it dynamically by analyzing slice information running on the signaling layer. So this is fundamental. I logically added here on the all layers. Now all locations. So we all know that attacks can come from the internet. It's obvious. So you do need denial of service there. You do need security mechanisms on the internet. What about roaming and peering? You need security there because attacks can come from the roaming, peering, and not from the internet. What about attacks coming from infected devices? It's coming on the run. And more we have sharing run. So more and more it's like internet interface. So security should be done on all interfaces. Otherwise, it's once again, there are so many doors that are open and you are then securing one of them. Third one is all attack vectors. Here, it should be malware and ransomware and threats and command and control traffic and remote code execution. All these things should be taken care of, not only layer 3, layer 4 security. It will be irrelevant in moving industries for the 5G ecosystem. And the last one is all software lifecycle. Till now, we talked about runtime, but security should be done also before runtime, CI/CD, and all the way shift left to the DevOps. And all of this in automating machine learning and artificial intelligence manner. I can give you several examples. Day 0. Initially, it took us 5 minutes to detect day 0, analyze it, and then distribute all over the globe protection. Now we are doing this in real time. Day 0, first time we are seeing attacks. We are analyzing it, building prevention, and distributing in the real time. Another example of automation is that we can build security policies per real user ID. IP is irrelevant. IP is changing all the time. What is your real user ID? Your SIM card. What is your real equipment identity? Your IMEI and 4G, right? So we can do a lot of very intelligent security policies based on intelligence of 5G. 5G is very intelligent. Use it for security. Just don't put everything over 5G. 5G is extremely intelligent. And when you are investing in this, use these capabilities for security. OK, this is my example of slicing. This is really, really simple. Today, you can do static slicing. You can, for example, traffic in the power utilities. You can put all the traffic coming from specific power utility company to dedicated P gateway in 4G core. And majority of cores in Europe and in America are still 4G. 4G, what is still 60% of all the traffic. So in 5G, of course, you have corresponding mode. But in 5G, there is a huge advantage. You can do slicing dynamically. You don't have to dedicate slices statically. From my perspective, it's the biggest technological advantage of 5G, really end-to-end. So you can give different security policies, in addition to different bandwidths and different quality of service, different security policies per different slices. The moment you are doing this, it's from the cost center. Now it's a profit center, because different enterprises can pay different premium for different security levels. And security levels, I can give you so many examples: DNS security, URL security, threat preventions, day 0 detections, dedicated IoT security capabilities. A lot of things that you can add per slice and give different verticals, different enterprises, different security slices. And at the end, I would like to add something personal here. It's extremely exciting to work in this space. And I feel we are changing the industry. We are changing how enterprises can do digital transformation by creating this ecosystem, creating this structure, how security should be done. And I strongly believe it's really protecting our digital way of life. So this is my 10 minutes. I will answer questions after that, just behind the wall. And thank you. Thank you for listening.
So instead of me introducing each of you, I'm sure you know better yourself. So what I'm going to do is going to ask you, all of you, if you can introduce yourself, give a little bit brief of what your company does. Right. But then let's start with one question also, so that we can kickstart the conversation. So the question that I want to ask is a little bit of, well, when we look at the industrial, so in the adoption of 5G technologies, we are still at the beginning. So what are the challenges, the barriers to actually the adoption of the 5G? Great. So if you can start, I go in this way, please.
Thanks, Barbara. Hi, everyone. Larry Socher. I joined Eseye back in January to drive strategy and alliances after spending 26 years at Accenture. At Accenture, I used to run the cloud offerings globally, cloud and infrastructure, as well as the enterprise network practice and the service provider practice. I had a lot of experience in IoT from different angles. Currently at Eseye, if you're not familiar with Eseye, we provide global device-to-cloud connectivity powered by AnyNet Federation, where we do more localization with up 16 MNOs right now, including AT&T and Verizon in North America, and that allows us to do support difficult geographies. It allows us to do low power networks, NB-IoT and Cat-M. And so it's pretty important for that. We also have an Infinity platform, which does a rules engine and ML that allows optimization. But probably more interestingly is we have a whole bunch of device intelligence capabilities. How do we put it's software that we can embed in the device to get network selection and optimization, which is a difficult challenge. If you look at 5G and the industrial sector, most 5G to date is really adoption is EMBB in the consumer space. So we haven't really seen it in the enterprise side yet. However, we think the real promise of 5G that really differentiates itself is ultra reliable low latency communications, which you saw previously. And in the industrial space, that's really important. If you think about manufacturing control, if you take a look at autonomous vehicles, if you look at the augmented reality that was in the Microsoft charts, you need very low latency communication to pull that off and reliable. And you really can't get that with any other technology. So 5G is critical there. Now, the difficulty in deploying that is it's hard. If you think about what you need to do to deploy network slicing, you saw 3 slices there, but it can be much more granular. So it's very hard to deploy and operationalize that environment to get there. The other thing that's difficult in the industrial sector is a lot of times in a factory you're in very noisy environments. So what we anticipate is URLCC will be the killer app for 5G adoption, and it'll be on private networks. So just given the need to engineer the networks, the lack of public support. So we think those are the challenges.
Thank you for that. Then we go to Andreas. Over to you.
Yeah, good morning, everybody. Andreas Roessler. I work for Rohde Schwarz in the technology management department. So I make a prediction. I think all of you have a phone in your pocket, right? So basically, we manufacture test and measurement solutions to test those phones in R&D for all kinds of things, RF testing, protocol, and such. But we also not only doing that, we also have a test solution for mobile network testing. And to assess network performance. And to echo a little bit what Larry already said is, our belief is that basically we are in the early adoption phase because the features are not yet there to be deployed. If we look at the network performance that we see right now in early deployed enterprise networks, they don't distinguish much from what public networks do. Simple reason, release 16, 17 features are not deployed yet, nor on the network infrastructure side, nor on the device side. So that has to come to really serve all these use cases. And of course, it's important to monitor the performance of these KPIs. Latency was already mentioned. And we developed over the past 2 years, while having an own 5G network running in one of our factories, tested our solutions there, and by the time the industry is ready to really deploy 5G for industrial IoT, we could assess and help to do the network measurements so that you can rely on this network and you get the functionality that you need to run your applications.
Thank you for that. Then Andy.
Hi, good morning, everybody. Hope you guys are having a good show so far. My name is Andy Robertson. I work for Nokia. I work in business development for private wireless in North America. So my main function is really the evangelization and love of private wireless. So basically, when I think about, all right, what are some of the things that are holding back private wireless adoption today? And I come at it from a BD type of a perspective. It really comes down to education, quite honestly, with a lot of the customers. So a lot of our customers we talk to have been using Wi-Fi for a very long time, and private wireless is a complementary technology to Wi-Fi. We never go into a customer saying, hey, we want to rip out your Wi-Fi network that you've been using for the last 20 years and use private wireless. What we say to them is, hey, let's go ahead and understand what are some of the applications that you want to use to take off the Wi-Fi platform for whatever reason it is, put it on the private network and move it that way. And so once we get the customer comfortable around that thought process, but also the education of it, and most of the customers that we sell to are managed services customers. They're not operating these networks. A lot of these IT infrastructure companies or IT departments are operating these networks themselves. They're used to running those things. So, you can definitely operate a cellular network yourself, but you need to be pretty sophisticated. And it's not an easy thing to do. So for me, when I think about, technology, is it there? Yes. Do we have end-to-end taken care of? Yes, for 5G. Obviously for 4G, we have licensed spectrum we can deploy. We have CBRS we can deploy here in the States. It comes down to education and comfort of the customer. And some of that is POC, and some of that is just, some customers are aggressive and want to jump into it and start going. So that's kind of my thought about that.
Thank you for that. And then we conclude with Shamik.
Yeah, thanks for inviting me. I'm Shamik Mishra. I'm the CTO for connectivity in Capgemini. Primarily responsible for our telecommunications strategy and architecture. I don't know how many of you know actually about Capgemini, but it's a IT R&D consulting services company headquartered in Paris. One of the stated strategy of us is what we call as intelligent industry, where we believe that there is a convergence of technologies that is driving a new transformation for industries. And this is about connectivity, data, edge, and cloud. And when these things come together, we are able to develop new experiences for our customers, industrial customers, and also we are able to perhaps generate some efficiencies around their operations. And that's what the focus of our intelligent industry strategy is. One of the key aspects about that is whether 5G can really be adopted at the speed at which we all expect it to. And a number of barriers were already covered, including the fact that there are features which are still pending, there are lack of devices and stuff like that. But the key challenge perhaps for us in the industry is the ability to map the 5G requirements to an industrial need. So if there is a PLC or if there is a large port, and there are shipping containers moving in and out. So what exactly 5G technology, what is that exact 5G technology and the edge technology that we have to bring in order to make that problem work? This also has to derive from a return of investment perspective as well, because enterprises will invest in a certain technology if it actually impacts their core. And it cannot be a peripheral science project, which somebody mentioned earlier, where there is an adoption of a technology, but it's primarily focused just on 1% of their overall impact. And we'll discuss more perhaps today on what could those be, but definitely edge computing is turning out to be a very important element to drive this transformation because of the fact that it brings in the ability to make industries more intelligent by leveraging data. And if you have to transfer data from point A to point B, what best than have a connectivity solution like 5G? But still, we have a distance to cover here.
Okay, thank you for that, for at least sparking a little bit of the barriers and the challenges. So if we look at a bit more on the infrastructure, and there are a lot of challenges, as you already mentioned. So, but what are the actual challenges or the question that we have to actually to address as an ecosystem? So what is that we have to look at for answering and work in a specific area? So if I maybe start with you, Andy, if you can give an idea.
Yeah, absolutely. Thank you. So when I think about infrastructure challenges, I'm not too wrapped around the axle on that. When I think about private wireless networks, what we do at Nokia is we have a core, we have end-to-end all the way to the end user devices. We have radios, we have switches in between all that stuff. But really it comes down to understanding what does the customer's, let's say it's an indoor application in a manufacturing facility, what does the customer's current IT environment look like? Do they have switches available? Is there Ethernet that I can run? I put PoE over it. Is there end spots where I can put the stuff? So I have to be very diligent about doing the design. Where's the use case going to be needed? What kind of density do I need for my, we'll call it APs for lack of a better term, and deploying them in a manner that is cost efficient. So once again, it comes down to understanding what their environment looks like and then doing those things. But I don't really see, from an infrastructure perspective, nothing cannot be overcome. We deal with a lot of very intense manufacturing environments all over the world, and it's just a matter of understanding what the application is, where you want it to work, and executing the communication to it. So I think we're there. I think I'm pretty
You're
comfortable
positive.
with it.
You're positive that we can.
Very positive, very happy and positive.
Maybe I come to you, Larry. What is your view?
Yeah, I think one of the first questions, is particularly in an industrial environment, is do I need a private network? And if so, do I need to then roam to and from that private network? I can't tell you how many deployments I've seen out there where someone's building a private network and haven't considered roaming. So then what happens when a truck, freight truck or something comes into a facility, into a manufacturing facility, and it wants to roam onto the private network or vice versa. And that's not trivial integration, particularly because you're spanning an enterprise network and then roaming onto the public environment. So you may want to look at how you do your MZs, like what you put in there. Do you have a roaming capable network, and what's that integration look like? So there's interesting things there. Then you're hearing a lot about edge compute, and I love Gartner's quote that by 2025, 75% of all processing will be outside the cloud. I'm really, whether the timing's right or not, I'm bought into that direction. You heard a lot about that now. And one of the things you then need to look at is, well, where's that edge compute going to happen? Is it going to be on the device? Is it going to be on the edge aggregation computing environment? Is it going to be in the Mac? And what's interesting, if you've been around IoT applications a lot, you'll know that they're very dynamic. They change and they flow as they deploy. So I may need to move around where I might have an ML computer vision workload to do predictive maintenance. It may move from the device into the Mac, et cetera. So it means when you design that network, you're going to have to engineer for that. I may have to, if you're familiar with the 5G user plane function, the data bearer, I may have to, just like I'm talking about slices, I may have to move that for a local breakout to get to edge compute. So there are a lot of, there's incredible power with this, but it is very, it is very complex to deploy and even more so to operationalize. And I think those are some of the questions you really want to address up front, because if you don't design for them, you can end up getting yourself into a corner where, hey, I can't roam now.
Good. Then I maybe come to you, Shamik, for the same. So from your perspective, what are these challenging questions we need to think about and answer?
Yes, I think a lot of the infrastructure part was covered by Andy anyway, and it's not a big problem actually to deploy the infrastructure. The real challenge is to make applications work. Because there are devices, there are applications that are being built. These applications are built by the developer ecosystem, third-party companies. And if we don't give them a platform which can enable them to build the software and deploy, monitor, and manage at scale, then it won't work really. And that's where the MEC concept comes in. However, as always, we have multiple different types of platforms, which we often call as MEC. Each of them have a different developer model, different ways of developing applications, different ways of integrating applications. The APIs are not always the same. So imagine a company who is developing an application for predictive maintenance has to maintain 10 different versions of the same applications because the infrastructures are all different. Now, that's not going to really create an ecosystem. It's dissuading. So one of the things that we in GSMA, we have started doing is the GSMA Operator Platform Group, which I happen to co-chair, is to standardize a set of APIs, at least a minimal set of APIs, so that application integration can be simplified. Now, whether it's on the operator network or on a private network, that doesn't really matter, because end of the day, it's all about having a 5G connected MEC. So from an infrastructure standpoint, the key aspect is application integration or use case integration. If that takes weeks and months, and then an upgrade takes even further, several other weeks, then that's not really going to make this work. So that's the critical infrastructure barrier that we need to cover.
Okay, so 5G, as you mentioned, is actually, it gives us a lot of tools that we can use. But because it gives us a lot of tools, obviously it becomes more complex. You have the flexibility at the cost of complexity. So if we look at to use all these tools, maybe I come to you, Andreas. So when we look at 5G and also in an industrial type of environment, in order to harness all these tools and the capabilities of 5G, what do you think actually are the skills that we need to build? So looking more at the factor two, how do we get there to use these tools?
So it's a very good question, and we asked the question ourselves, and that's the moment when we decided we can't just market our solutions to do 5G testing, network testing, device testing, if we don't have any experience in the industrial IoT sector. So based on that, we decided to use one of our factories in Germany as the guinea pig, in particular the IT department there, right? So because they manage, like, I think that was already said, like a very complex Wi-Fi network already for the existing use cases. And we came up with the idea, hey, why we can't use an infrastructure supplier, partner with them, and install a 5G network, right? So in Germany at the time, they set aside 100 megahertz of wireless spectrum, very precious wireless spectrum, 3.5 gigahertz for private networks. So we acquired a license locally, and then we got into a whole thing like, okay, what do we want to do? Do we want to partner with an operator? Do we want to become our own operator? And we said like, well, the most challenging case is probably later. So let's do that, right? So we like challenges. Well, we didn't know what we get into. I can tell you that, right? So the good thing is if you have a service level agreement with the infrastructure provider, because they need to help you, and it's not plug and play from our perspective. We had to work over the last 2 years. We deployed non-standalone mode because standalone mode was not there. But anyway, we wanted to gain this experience using our tools, optimizing our tools, so by the time other people do it, that they have already tools ready and available to do the assessment, to measure latency, to confirm the required latency is there. And it goes to simple things like that. You bring a device in, you have a SIM card, you put a SIM card in, and it won't connect, right? So now you start to do the investigation. And of course, like the commercial operators have a lot of experience in that. But if you do it by yourself, there's a lot of work to do and consider here. And tools for that are necessary. So we started to do own test cases on our emulation platform to test devices before we bring them into the network. And then we used our already existing optimization tools to optimize this network. We just recently, this month, we started to upgrade to Eseye. So now we are in the position basically to look at all these use cases that we addressed today with Wi-Fi and determine which of the use cases we can use now 5G for. So it's to tweak and twist, obviously. So, like I said, we had a lot of help from our infrastructure provider in doing so. And while we continue to explore in these scenarios, I think we will develop better solutions that then hopefully everybody can benefit on when they deploy their own 5G private network, either as a slice from a network operator or their own.
I don't know if you are in a position to say, but how much time did it take you to get here?
So we made a decision early 2020. We started deploying July 2020. We announced in November 2020 that we have a network. So now it's, October 2022, so it's 2 years.
Okay.
It was early. It was non-standalone mode, right?
No,
so
like exactly. So, but let's give it a list and indications,
yeah.
You know.
And devices that we have is, like I said earlier on already, it's not released 16, 17 yet, so we don't have ULCC to the degree that we need it. There's no slicing,
early,
so
yes.
there's a lot more to do.
Yeah, I understand.
Case, yeah.
So then maybe we're gonna do one question for all of you just to close. And if we have still time, then maybe I come to you if you have any question for them. So if you had to do one piece of advice for who wants to start in using 5G technologies in industrial applications. So maybe I start from you, Shamik. What would be one piece of advice where you say, maybe look at this, we'll start from here? I know it's difficult to say one.
Yeah, it's a difficult question. I think the most important aspect about deciding whether to go for a 5G and if so how, is to understand how the 5G would be really leveraged for a use case in terms of acquiring data in a manufacturing shop floor and then leveraging the data to create some applications or use cases, whether it's new experiences or otherwise. So the end outcome, I think, is critical to take a decision of what kind of 5G private networks or what kind of edge technology would have to be deployed. And so the decision about the use case also means how they would build the use case, whether the devices, the applications, the infrastructure, all has to be in such a way that it's easy to integrate. So do not underestimate the effort of integration. That would be my advice, because that's a complex piece of work in 5G.
Thank you for that. I like also what you said, that you need to know where you're going. So at least you know where you're going to get in order to choose the right path. Or Andy, what would you give as an advice?
My one piece, which is in 4 different sections. So when you think about talking to a customer, we talked about education earlier. And so really the first question that I always ask to a customer is, tell me what you know about private wireless. And we need to get them to a certain base level of understanding of what makes it different than Wi-Fi? Why would you want to do certain things? And the next question, is like we're talking about, is really what specific one application do you want to use to start with? So private wireless networks, the main value of them is to securely move information from back-end databases and applications behind your firewall securely through the air to the end user device, or to acquire information from an IoT sensor to use for one of the other gentlemen earlier on the panels, his systems that allowed for deep analytics on those things. So really, first thing, understand what the customer understands, and then talk about that one application, and then we go from there. But really, when you're talking to a customer, where you're talking about anything, experience matters. If you're going to choose a partner, choose somebody who's doing it. And the discussion is not about me pulling up 50,000 use cases that might work in a manufacturing environment. It's okay, tell me about which use cases you have deployed and what is the ROI of those use cases today with your customers. If the person cannot answer that for you, you need to move on to another vendor. So that's my 4 parts to the 1 point.
There you go. So, Andreas, how do you?
Yeah, obviously we have to say, don't forget measurements, right? But in all seriousness, it's always the last thing that people think about. We all see the great demos here, right? And they're all working well and showing the greatest performance ever. But having that ready and available 24/7, 365 days a year, that's a challenge. And test measurement can help find, early problems, interference scenarios that all of a sudden being created because somebody warms up his lunch in a microwave oven, and all of a sudden the robots don't talk to each other anymore, right? Because there's interference created. So don't forget that while you fixing and solving all these other very important things. I don't want to say they are not important, but think about that as well.
That makes sense. Okay. Larry, over to you.
So once you've decided that 5G and maybe for your LCC is the right technology for the application, so take manufacturing control or augmented reality that we saw earlier, one of the most critical things is to start with the device. It doesn't matter how good your network is. It doesn't matter how good your management capabilities are. If you get the wrong device design, you're dead in the water. I mean, if you aren't designing connectivity, all the flexibility into that device so that it can adapt, it can change over time, you can have a sunk investment. Collider Research actually recently published an analysis, and they interviewed about 750 enterprises globally, and they asked, what are all the challenges you're having deploying IoT? And while roaming, there's all these other major issues. 84%, by far the biggest, the highest number, was actually device design, where people are having challenges. And if you see the industry numbers, 80% of all projects fail. A lot of that is device issues. So get started early on the device, and that it's actually been more systemic for 5G and more on the IoT side is the difficulty on the device side. So get out in that early and really make sure you've got your ducks lined up for that.
It's quite a good distributional list of points of things that we need to do. We have actually 1 minute, but I saw that there is a person with a hand. I can just. Are you good? Okay, please. Behind you. Yeah.
Yeah. Hi. Thanks. When it comes to designing the right device, are you talking about data collection or the other behaviors of the device in terms of how it communicates beyond the data collection layer, which is
and it's everything. I mean, one of the things that was talked about earlier was the need for full stack. I mean, if you think about it, an IoT application, it's not the connectivity, it's not the device that delivers value, it's the apps and data that ride on top of it, right? So you need people who can do full stack integration, and that device needs to do everything from what sensors and capabilities are embedded in it, what are the applications that are running in it, what's the operating environments, if it's a non-power, battery-powered device, power management, compute management, and maybe the ML workloads for computer vision, and then with the underlying connectivity. And that connectivity has to be tailored so that it can support whatever those application requirements are on top of it. So if it's computer vision and it needs to send a significant amount of data up and it's doing some ML processing down, I need to make sure I'm tailoring my communications to do that. Now, I want to be able to design the device with some flexibility so I can change my application models, you do more compute locally, for example, or transmit more into the cloud for aggregation. If I can get better ML models that mash up other data sources. So making sure when you're designing the device, everything from the connectivity through compute, power management, is done in, you're addressing the issues early and designing the flexibility so that if something does change and I decide, hey, I'm going to move ML workload from the device to edge, I have the ability to handle that in the capabilities.
You want to continue? Or,
No. Good point. The key is, today we have this something called universal CPE, correct?
If you can be brief, because we have like 10 seconds.
Universal CPE for equally applicable to all the enterprises, correct? Including the manufacturing. Now, that universal CPE model is debatable. Actually, there are use cases today. Could you comment on what is the shortcoming of the?
I actually, universal CPE is very good for enterprises and for but in general use cases, I don't think it applies to IoT. I mean, you have very custom devices, and I mean, one general thing about IoT is every use case is different. And that's been one of the challenges. So you may have some general capabilities on how you embed the stuff with like microprocessors, but almost every device is different, and its requirements are different, and its optimization requirements are different. I'll give you an example. An asset tracker, I can take some downtime for cost because I've got hundreds of thousands of millions of them. But if I have a remote patient monitoring device, I can't. So every requirement's different, and I don't. And you need to make sure that device design understands and gets flexible communications built into it, because it's very likely it's going to change throughout the life, particularly if it's like going to be deployed for 10, 15 years.
So yes, we are out of time. So I want to thank all our panelists, and I hope it's been useful for you. And I hope to see you then next year, the same time. So just wait a second. I have just some information, I think. Here, there's also, if you are interested, so we have, let's say, a forum in GSMA where we talk about these topics for the industrial and how to use 5G. And some of the company that actually participate in and lead in that forum are also here. So, but if you're interested to join and you want to learn more, you can take the QR code, or you can come to me afterwards. I'm going to be there, so I can give you more information. So please join us, because as I mentioned, there's a lot of things we need to learn, share, and there is complex area to look at. Again, see you also next year then. Thank you very much, and please give it a warm welcome and thank you to our panelists.